Thanks for having me today. It's my pleasure today to go over a comprehensive guide to fabricating all-in-X cases. A little bit about myself. I've been in the industry for about 17 years. Graduated medical high school for dental technology in Europe. Studied at New York City College of Technology, restorative dentistry in the States, and I worked with various implant manufacturers and dental labs around the country to basically streamline the protocols for all-in-X fabrication as much as possible. So I try to bring a little bit of that clinical and lab experience sort of into one so that the process is as painless as possible. So we're going to focus talking about all-in-X restorative today, but I want to mainly talk about DES. The reason why we have seen a lot of success in doing all-in-X restorative is because we were able to find DES as our partner for implant restorative parts. So before we jump on how to approach these all-in-X cases, I just want to quickly talk about some of who DES is, what they do, and what they offer. So they're family-owned operated business. They have a pure switch concept, which allows you to switch from OEM platforms directly onto their platform with 100% fit, and they exist in multiple markets. Their multi-unit abutments are very versatile, and we use them all the time. And they're also 510 FDA cleared. This has become really important for us and other manufacturers to have components that have been verified in high quality so that we know that we're getting a consistent product and we're seeing consistent results. If we look at in terms of their offerings, just to break down, and which I'm sure most of you know this, they utilize scan bodies, but there's 3 different types. So you can use the one on the left you see is the intraoral scan body, then the one in the middle is the desktop scan body, and then you even have the ability to get one of their tie bases and 3D print your own scan body in case the dentist doesn't have it. So if the dentist took an impression and sent it to you don't have a scan body, you can actually 3D print an STL file that they provide you, and you can snap that over the tie base that you have, and that becomes your scan body. So very versatile in that sense. Their libraries are extensive. They support a 3Shape, ExoCAD, and even dental wings. So very comprehensive list of libraries, and we're going to later touch on to how expansive their libraries actually are and why they're so useful. When it comes to digital analogs, they do provide a digital analog. Recently, it was released a newer version of digital analog that has a screw at the bottom. So this way, you know that when you place the analog on one side and you can screw it on the other side, you get that stability that you sometimes don't get when you do 3D printed models. As I'm sure you know, if the analog to model spacing is not quite correct, you can get a lot of wiggle room there, and that's usually a main complaint that some people have about doing implant restorative dentistry with 3D models and its accuracy. Of course, that analog can also be used for stone models as well. This is a good slide because I want to talk about Select Grip. They call it Select Grip. Basically, what it is, it's a special coating, sort of like a pre-sandblasted, pre-prepared coating on the tie base. That allows 5 times improved retention compared to a machine surface. So it's a lot of labs have tendencies, a lot of technicians have tendencies to pick up a tie base and sandblast it with like a 50 micron aluminum oxide, and then go ahead and apply their cement and go ahead and cement the crown. We actually found that if we did not mess with the pre-treated Select Grip surface, that we were actually getting no cementation or decementation whatsoever, and then long term we find this to be a much better solution. So we actually this is the only tie base that exists that we know of that actually has this sort of coating that does not require any sandblasting treatment. So very useful, and for also long-term consistency. And of course, the angulated screw channel. That is their tie base that is ever so slightly shorter, but a little wider, that allows 360-degree freedom of positioning with up to 25-degree angle in one particular direction. It's a great solution for when you need to address some of those anterior cases with screw channels ever so slightly close to the inside of the ledge or going slightly through the facial, that you can bring back 25 degrees. We're going to touch on all these in more detail as we go along. So Zirconia is strong and self-supporting even with very long clinical restorations, and once cemented, entire complex acts as one. So what does that mean? So it means that a lot of people are concerned about how short some of these tie bases are. But I actually look at physics as once they get bonded into one piece, the force doesn't work as a cantilever force in that sense. So any higher shaft will block translucency and compromise final aesthetics. So you need to have a slightly shorter tie base to allow for that 25-degree angulation. Otherwise, there's a lot of color that shows through if you have a taller chimney, if you want to call it, or taller cylinder. A lot of manufacturers have a system where they basically have a temporary cylinder with one side cut off, and then that sort of acts as an angulated screw channel. But it's really not a practical solution. And the pivot point is in the connection between the titanium base and the implant. So it really acts as a one piece. Multi-unit design, I'm sure you're all familiar with multi-unit abutments. As we talk about All-on-X restoration, we're mostly assuming that dentists are restoring these cases with multi-unit abutments. However, that's not always the case. And there are many instances where they don't. We always lean towards utilizing multi-unit abutments for a variety of reasons, such as ease of use, path of insertion, correction, and of course cleansability, so that the entire restorative is brought at the tissue level versus you having to fight tissue subgingivally to insert your restoration, which is what happens most of the time where some of these implant level cases don't work out. So considerations when choosing restorative parts manufacturer. So when I was hired at Aurora, I was given one goal: streamline the entire implant production, make it as simple as possible, make sure that we give people a good customers a good quality product, and that our restorative is consistent. So these days, as a lab owner or a manager, when you look at these things, there's so many factors you have to consider. First is implant manufacturers. You have to familiarize yourself with which implant manufacturers you're mostly working with. So you have to ensure that the provider of your implant restorative parts supports those manufacturers. So you have to choose, are you going to do OEM, which is original equipment manufacturer, or are you going to do a third-party 510 FDA cleared? Then you have implant supportive, which systems are supported. You have to consider if there are dozens and dozens of different implant systems supported. So for instance, you have in one part of the country, you have Nobel, Straumann, or Zimmer. But maybe in your area, they use a lot of other different implant systems. So you have to make sure that whoever's providing you with restorative parts has a wide variety of implant systems that they support. Then scan body variety. This has been an ongoing fight throughout in the last, let's say, 10, 15 years. Each implant manufacturer has created one or two or three different revisions of their scan bodies. And then has released two or three different library files for those scan bodies for different versions of CAD software. So you can imagine what kind of logistical nightmare that can create to make sure that the lab, the clinician, and the manufacturing is all sorted out under a single umbrella, supporting an easy workflow to take the case from the beginning to the end. So what happens if your lab only has a library that only supports the revision 2 scan body, but the dentist uses the revision 3? Are you going to call him to reschedule the patient to rescan with the old scan body, or are you going to spend time on the phone trying to download the new library, but then that library only works with this version of the software, so you might have to upgrade that as well. So it's become really complicated to kind of sort everything out under one umbrella. So that's what we look at. And then software libraries for 3Shape and Xrays. We need to know that we have the option for both of these CAD softwares to be properly supported. They both have their strengths and weaknesses, and so a lot of centers utilize both. Then you need to look at things like, does this manufacturer provide engaging or non-engaging parts for straight and angled applications? So sometimes as they roll out products, a lot of manufacturers only provide certain product lines, so they don't always have they don't always cover every scenario for your restorative needs. And then when you get through all that noise, then you start to think about smaller things like angulated screw channels, pre-sandblasted surfaces, like we earlier mentioned. Are they gold anodized? So this way I don't have to worry about a lot of that gray halo showing through either at the gingival cervical line or through the crown itself. And then ultimately, if you really want to get picky, can this place be a one-stop shop for me as a manufacturer, as a lab, and as a clinician as well? Meaning, if my dentist needs a part that he doesn't have, what they usually do, they call the lab. Oh, you have an impression coping for this, or you have an analog for that, or and so on, or driver for this. So this way, you want to find a manufacturer that kind of has everything in one as a one-stop shop. This is why we turn to DES. And we know that they can provide multi-root abutments to the clinician, drivers, impression copings, analogs at the same time, provide all the other titanium bases, pre-milled blanks to us as a lab. And Fran, I believe we want to ask a poll question here.
Yes.
Yeah.
I'm going to launch the first one right now, if that's okay. So are you fabricating all on X cases using DES components? If you wouldn't mind answering yes or no. And we'll keep this going just for a couple of minutes, just for like a minute, if that's okay, Milos. You could.
Yeah, that's fine.
Yeah, people are still answering, so thank you so much.
I'm curious to see.
For the results at the end, right?
Yeah. Okay, perfect. So why screw retain? So here at the lab, in order for us to streamline this production as much as possible, we kind of decided to lean more towards providing, creating screw retain restorations versus cementable restorations. So I will be considered probably a preacher for the cementable, for the screw retain restorations. That's not to say that there is no application for cementable restorations, but I think the latest technologies from companies like DES and different software solutions have allowed us, and machining solutions are really allowing us now to really make most of our restorations screw retain, implant restorative. And there's also, I want to make a case for why I think doing screw retain is important. So number one, we have retrievability, servicing restoration over time. Then we have less moving parts, which means only one cementation layer versus zirconia abutment and a crown that would usually come. No leftover cement in the mouth. So therefore, it's more long-term reliable as the cementation process is done in lab in a dry and clean environment with proper setting times and not rushing between patients, and significant ease of use during insertion and removal, especially on something like a larger case. So here, for instance, for the retrievability, for instance, if you're going to do custom abutment and do a cementable crown and you cement that crown, if anything goes wrong for whatever reason, what are you going to do? You're going to have to cut that crown and remove it and de-cement it from that abutment. That is a very arduous process. I've attended a lot of sessions with dentists when that has been performed, and it's not fun for the patient nor the dentist. Zirconia is a very abrasive material to a lot of the burrs that we use in the industry. So in the case of a screw retain restoration, you screw the whole restoration in with a tie base cemented with a crown. And then if for any reason you need to assess the adjacent teeth or restoring them in the future, or you need to have access to those interproximal areas, you can take that crown out, prep the tooth next to it, put the crown in. You can also use it in cases where the tissue or the health of the implant needs assessment, therefore a review over a course of time by either the surgeon or the restorative dentist. So having the ability to take that crown in and out is really important to do it with ease. Then we have angulated screw channel. So this is obviously transformed, not just for us, but I'm sure for many of you, the ability to convert a lot of what was the main benefit of doing cementable restorations was in an anterior section. If the implant was usually flared out, and happens all the time because of that's where the bone was, right? We end up having a screw channel that goes right through the incisal edge, or through the facial, making it, if it goes through the incisal ledge, making it structurally problematic when you bite things, or if you go through the through the facial, through the labial side, it becomes a aesthetic issue. So with desk components, we have the ability to move everything 25 degrees lingually. That is the max. Now, the less of a degree of movement you have, the easier it is for you to access that screw, but it has been rated and we've had success with going up to that 25 degrees. The software wouldn't let you go anywhere past 25 anyway. And so that it takes into account the length and the width of the screw when it creates that screw channel. And even in the latest version of 3Shape software, the 2022 version, it even creates sort of like a little a cutout area right at where the screw meets the tie base. It creates even a little extra hollow space in there, so the algorithm is actually getting even better and more accurate to allow for that clear path of the screw to make it down. Here
we have one more,
and
I'm going to launch that now. Are you using angulated screw channels? You wouldn't mind answering. Thank you.
Yeah.
So only take like a minute or so.
Hey, if they're all using desks and angulated screw channel, I'm done. I can just sign out and you guys are doing great.
So I'm going to end this poll. Thank you so much for answering.
Perfect. So here, I just want to show you sort of like the degree of freedom that you have when you move these channels. So yes, the general use is for you to go to the lingual, but sometimes in cases where, let's say you have really flared out implants at the gum line, you might have to flare them out actually facially so that the doctor can screw it in head on at the tissue level, close that tissue with pin composite, and then the rest of the restoration just sits there. But yes, you have the freedom to basically move that channel in multiple different positions. Other manufacturers who also make implant components, other third parties, they have the ability to do screw channel, but sometimes they can only go up to 15 degrees or so. And because they have a cutout on one side of the tie base, they only allow sort of like 4 or 5 different positions for that channel to go to. So it's really not giving you that full degree of freedom that you want to have for that movement. Cementation process is done in lab. This is what I say was really important. A lot of times, I'm sure you've seen it before, the dentist would go ahead and take a custom abutment, cement it. What do we have? We have saliva, we have humidity, we have bacteria, contamination, and we also don't have a lot of time chairside. So they go in, slap that cement in, put it in. Who knows if that cement has even been cleared out correctly, if the setting time was done right. In our case, we need at least 15 to 20 minutes for the tie base to fully set, the cement at the tie base to fully set, which I'm sure in most scenarios in office is not the case. So this is the benefit of doing a cementation process in a lab. So you're getting, when it comes to longevity of a screw retain restoration, you're getting, that's where that comes from. So why is it important that there's no leftover cement in the mouth? So working side by side with clinicians, I've had the privilege to see what can happen when there's leftover cement. So long term. So a lot of that cement falls underneath your tissue. It can stick around the implant if it's really subgingival, or it can just hover right there in the transmucosal area. That's the area that you see here. That's the area you don't see that's under the gum. And then over time, it can create plaque. That plaque can cause inflammation. It can cause recession, and it can potentially, even if it's severe enough, cause an infection that can result in you losing that implant. So really important that entire transmucosal area is as clean as possible, and they can only be done with a screw retain crown that's been cemented extraorally, so in the lab in a dry environment. So as you can see, that's the stuff that you don't see, and very crucial to get that area correctly. So here, pardon me. Here, there's an example we were talking about. Every time I show this slide, the first thing everyone says is that crown is way too long. There's no way that tie base is going to support that. So in reality, think about it. So one part of the concern is that, but our research, at least internally here, and what we've seen in terms of failures, has been more focused on cantilever forces destroying our screw retain cases versus a vertical force that just goes up and down. So it's really important when you think about it in terms of physics, how lateral forces and occlusal forces work. And we found that where most of the failures that we see are coming from cantilever forces and not really from a situation like this. And then the second part is, if you can just picture this deep of an implant going subgingivally and getting screwed down and then having to clear the cement in that area, that can create a big problem for the dentist. So there's no way, it's really difficult for them to properly clean that out. So earlier I mentioned the robustness of desk library, and this is where I want to show you how does that really work. So a lot of times the lab will only receive a scan body that they support, right? So maybe they only use OEM scan bodies, maybe they only use third-party scan bodies. So what DES allows us to do is mix and match scan bodies that the dentist had used. So when you, let's say this is a bone level RC, I can switch it from intraoral scan body to a desktop scan body. But then maybe the dentist used original 3-shape scan body, which is this. So then I can switch to a 3D printed scan body, the one I mentioned earlier. I can switch to ELOS, because ELOS also makes scan body for that implant. Or maybe the doctor had Atlantis scan bodies for that implant laying around, and ultimately he might have used the OEM Straumann Cares scan body. So this allows me to not talk to my dentist, which is sometimes a good thing. Less talking, the better. But all joking aside, it allows us to really streamline it to a point where there's very little room for error. Very few phone calls, having to reschedule the patient or do like a total rescan, or order new parts and back and forth. So it allows us ultimate flexibility to switch these scan bodies and just receive the case from whatever they had on their counter that fit that implant to kind of like align and move on. Here, I want to show you, this is an example for 3-shape dental systems, how those libraries are organized. So if you look to the right, you're going to see the reference number stating 16072. So the way we do things is our designer designs a case for 16072, which in this case was Hyacinth Mini, and it writes that number on the work ticket. So now when that case goes to the ceramist or a staining glazer or whoever is going to finish and cement the case, they don't have to wonder what part they have to pick from the library. The good thing is that all those reference numbers that are actually used for ordering are also placed in the library. So on the left, you can see 16343, 16098. So it is very useful for a library to carry in itself, not just the name of the implant or some proprietary wording in there, but to actually carry the reference number of the part that you have to order. And very few libraries offer that. There are a few, but DES was kind of like the first and like the most robust in that sense. So there's literally no confusion or no mishaps when it comes to what tie base or which part needs to be ordered or goes with which case. So this is logistically created a very good situation for us, where we just communicate with each other in like these 5-digit numbers. Hey, give me 16072. I got a 16343 or 15042, and so on and so forth. So it's allowed us to really reduce the amount of error and to really work on these cases more comprehensively and efficiently. Great degree of freedom. So I like showing this slide. I just don't like showing it to the surgeons, but I like showing it to the restorative dentists and the technicians, because if I show it to the surgeons, then they're going to place all their implants with their eyes closed. But what does it mean, great degree of freedom? So this is what is theoretically possible with desk components, and how much of a correction we can create for the angulated screw for the positioning of the implant. So we start off at 0 degrees. That's how our implant was placed. Then we can get a desk multi-unit abutment that corrects it for up to 30 degrees. And then we can put a desk multi-unit gold anodized tie base that can correct it for another up to 25 degrees, which brings it a total of 55 degrees of correction. Of course, with appropriate vertical clearance. What do I mean by that? Every time you stack components on top of each other, you want to make sure you have vertical clearance because you're eating up that VDO that's available for you to restore that case. So I'll show you a case where we pushed it to these limits at the end of this presentation. So it is possible, but you just have to be aware of it. And this is why these components really allow us to move most of those cases that used to be done in a cementable fashion over to screw retained. And then we coined a term. I believe I coined it, but maybe someone else coined it before me. Regardless, I'll take credit. Clinically and functionally friendly screw channels. So what do I mean by clinically friendly screw channels? We don't just have to worry about is the case going to be aesthetic enough so that we move screw channel to the lingual and we're done. You also want to think about it in terms of knowing your clinician, knowing your dentist, knowing that is it going to be easy for them to insert and retrieve this case? So the tendency for us is always to move those screw channels to the lingual, but then tilt them over towards the midline. So if we tilt everything towards the midline, what does that allow us to do? We're aesthetically satisfied, right? Everything's on the lingual, but as we move it towards the midline, we're allowing the clinician to have very easy sort of like frontal access so that they can put the restoration in and relatively easy screw it in. If you leave the screw channel, for instance, going straight through the occlusal surface, yes, it's aesthetically pleasing, but you're actually, for those most posterior teeth, creating a problem, potential problem for the dentist to not be able to have the patient fully open their jaw and have 90-degree access basically going in and then screwing the restoration. So that can a lot of times create a problem for those most posterior teeth. So by moving that screw channel towards the midline, you're allowing the clinician, clinically friendly, to go put that restoration in and out. So it's also like an added benefit that you could say, hey, I was thinking about you, doc, and I did you a favor. So you can see here, we kind of like tilted everything towards the midline in the image, making it easier for the clinician as well. Then we have the importance of biomechanics. So on top of you satisfying the aesthetics, right? So now we're on the lingual with the screw channel, and we tilted everything a little bit to the midline to satisfy the ease of use for the clinician. Now we have to think about, is the restoration structurally sound? So a lot of times with a screw channel can very inconveniently go right on the interproximal where the teeth are. So this is a biomechanics issue. This is a physics problem. This is a structural integrity problem. So by utilizing angulated screw channel, you're allowing yourself to move that screw channel away from the interproximal area where you're structurally a little more compromised and move it to a more meaty part of the tooth, like a cingulum or like a nice occlusal surface, the middle of the tooth that has plenty of material around it. My experience has been when these big cases fail, it always happens between 7 and 10. So it's like a central lateral, or like the cannon where people bang most of their teeth right there and they move back and forth. And so when they place those implants, those channels can really get in the way. So you have to think about it. This is a third level of thinking about biomechanics when you move these screw channels. And then we have predictable fit. So the reason we've switched over all of this that I've mentioned allows us to get that predictable fit so that we can take that restorative, put those tie bases in with no adjustments, since the cement gap is very well calibrated and set in the settings from the library files. So there's really no adjustments we have to do on those tie bases when we put them in the restorative, and then just put them in the restorative and snapping them on the model. allows us to really have that consistent output if we utilize this workflow. So this is when our ceramists and staining glazers get this, this is what they like. And if now they're so spoiled, if they get anything but this, they throw a fit. So we try to keep them happy. This is an example. This is a Zirlux transitions, a bridge. This is an example of the finishing that can happen afterwards, after the bridge has been finished. But I also wanted to show the intaglio side, so you can kind of see what sort of profile these tie bases have, and the benefit of gold anodization. If you look at, there's one problem in this picture. Well, there's two, but the main one would be on tooth number 9. So in this instance, the clinician had refused to place a multi-unit abutment, and so we have this very elongated design. That happens a lot, and if it does happen, try to get a multi-unit in place as much as you can. If you cannot, then you have to be on the same page with dentists, understanding that that might be the area where you're going to struggle inserting the case, because as soon as you remove the healing abutment to put in your restorative, the tissue tends to shrink right away. And the longer that canal is until you hit the implant, the harder it is for you to insert that restorative. So the patient is in pain, dentist doesn't look happy, nobody's happy. So this is why it's important to bring everything at the tissue level, so you can have a better control and better reference for that fit. Gold anodized surface, what we mentioned, is one of those like goodies that you get with some of these tie bases. It's really important to have that, especially in the interior section, so you don't have to worry about the gray halo. But another reason why I included this slide shot is I wanted to show you how intimate is the fit between the tie base and the zirconia, and how there is no leftover cement at the seam, which is really important, because when you do your cementation, going over that seam, either with the rubber wheel or afterwards with glass beads, to make sure that there's no leftover cement, really creates that good sealed intimate fit. And the second reason why I included it is, if you can tell here, I have 2 Novell Active RP implants, and right at the very end, there is a Brennemark RP. And the reason I want to mention that is because more and more we're seeing patients who are older patients who've had implants done 20 plus years ago, but their restorative has failed, but the implants are still good. So now maybe they've gotten a few more new implants, and now they still have that old Brennemark, but how are we going to restore it? So this allows me to take old technology, I'm going to call old technology, and then restore it with modern technology, and sort of like take that non-engaging Brennemark angulated tie base, which not even the OEMs offer that on their own Brennemark platform, and restore it alongside all the other implants in one shot. So logistically, it usually creates a big problem. You have to buy third-party parts, call OEMs, what's supported, what's not supported. Nobody supports this platform. It's hard to get the parts, not with us. So it allows me, for a lot of these older patients who come in, and this happens actually pretty frequently, to have the ability to restore old technology with new tools. So I wanted to show an example of where we're talking about vertical clearance on All-on-X cases, how I'm really not, that slide where you see on the lower right of that big bridge, I'm really not concerned with that vertical height because I'm more concerned with upper left corner when you see those 2 screed tin crowns with that cantilever premolar. What we see over and over when it comes to these failures long-term, because you don't see it right away, is that anytime there's a cantilever force on an implant, it keeps doing this. And that's what decements your tie bases. That's what makes them fail. But in instances where we've had like really well designed, almost like at that 90-degree straight down a design where the occlusal forces just keep doing this, we're really not seeing failures there at all. So this is a comic, controversial sort of opinion. And every time I show this, there's at least 1 or 2 guys that always says, "I disagree with you. That's not true," which is hard to argue anecdotal evidence, but this has been my experience. So, and this is our case that I wanted to show. This is Maria at the Yorktown Dental by Dr. Valente. She was a sweetheart. She has been walking with that restorative that you see for years. It was very protrusive because no angular screw channel or options were utilized. She was very protrusive, very old, it was folding apart, and so she got some implants. But the way case started is the doctor called and had said, basically, Milos, you might want to sit down. The surgeon had a bad day. So as soon as I heard that, I kind of know what was going on. I mean, I didn't know, I anticipated, but then I found out. So these are the implant placements. This is the surgeon obviously had a bad day, and so now we had to find a way to restore this. So what I did was the doctor did a scan with intraoral scan bodies. It was just a sort of like a diagnostic scan, and so that scan allowed me to see where the implants have been placed, and I went ahead and designed a diagnostic setup that I thought fit this patient at the best. And then I overlaid that to see what are my challenges, right? So if you look in the upper right corner where the diagnostic wax up is overlaid with the screw channels, you can see that 7 and 10 interproximal could be a problem. 11, I'm sorry, 6 and 9, I can pretty much move that 25 degrees, no problem. The biggest problem is between 10 and 11. It is very labial and is 100% interproximal. So that one was going to be a problem. And so the doctor didn't really know how to assess what kind of multi-unit abutments he needs to get at which degrees and which depth. So this is a good time for you to utilize your intraoral scan and do some measurements. So you go ahead and you align your scan bodies, and then you go ahead and just measure the depth of the sulcus. And let's say if there's a 2 millimeter depth, maybe you'll get a 1 millimeter multi-unit height. You always go like a 1 millimeter below where the tissue is. So if it's 3 millimeters deep, you get a 2 millimeter multi-unit height. That's in terms of height. In terms of angulation, here we have to go ahead and basically see what are our tolerances. And when you overlay your diagnostic setup with the screw channel, you can kind of see how far you have to go. So then we made a list, we made a shopping list. Again, sent the dentist to the desks. So he acquired everything from desks. The parts, the multi-unit abutments, the scan bodies, the impression copings, everything. And then the next scan, after he got the abutments, he placed them in. And then he did another scan with multi-unit scan bodies on top of those abutments. Remember, this first scan was done at implant level. So now we're doing a second scan at multi-unit level. So on the upper left corner, you're going to see here that we created sort of like, we 3D printed the diagnostic setup that we did, and we did a vacuum form. He was able to place that vacuum form in place, and then that was sort of like a guide for him when it came to timing of the implants, right? The orientation of the implants. So this way he knows that he's not tilting it too far mesially or distally as he's putting them in. So that's a great tool to have. And after putting them in the most optimal position, he takes a scan with multi-unit scan bodies in place, and then we have that 3D printed model with the final position of the multi-units. So it's really important. I talk about all these things because a lot of times it happens to us that dentists really don't have the patience or the time to work with us on these cases, which is why you see failures, remakes, a lot of headaches. So whenever you do find a dentist that does want to work with you, you should feel blessed and keep him, because if you can really bring about, with all this technology and cooperation, it can bring about like great outcomes. So this is the picture of multi-units in place. The one problem that I see, and you probably see it, is position on number 6 and 7. You have a little bit of that cuff height showing. Thankfully, that was a trade-off, and thankfully the patient was not really showing much when she was smiling. So that was the trade-off we were willing to make in order to satisfy the case with a single piece screw retain restoration. So this is our design. So we went ahead with the new scan. We designed our PMMA. We overlaid everything, try to copy the diagnostic as closely as possible. As you can see, between 9, 10, and 11, we have that gingival profile that we have to create. And over on the adjacent side, we have a number 7 with sort of like showing a little bit of that cuff from the multi-unit. Again, these are all things you have to be aware of. There's some trade-offs, but if you look at where initially the screw channel was going, if you look at the upper right corner and where we were able to push it back, on the lower right corner, the final restorative, that has no screw channels showing anywhere. And that's what that's what that 25-degree allows us to do. Also, I don't know if you can see my mouse, but in the screw channel of tooth number 11, going back to biomechanics, we moved it over not just lingually, but we moved it over to the distal, where it was away from the interproximal area. Therefore, trying not to compromise that interproximal strength where a lot of that tension happens. And we 3D print the model, we make our PMMA restorative, put those multi-unit angle tie bases in, put everything in the model. So now that it's on the model, we have a really good idea of what that's going to look like in the mouth. Of course, when it went in, she was just ecstatic. She was so happy. As you can see, when she smiles naturally, she's not really showing anything past the gingival, the middle third of the tooth. And so when she's fully retracted, you can really see that everything we've seen on that 3D model is exactly the way it turned out in the mouth. And this is when it comes to that predictability, that we can always expect very similar, consistent result. So that tie bases, the way they fit, they always give us like that accurate reference. And so she wore that provisional for a while. After that, we did some X-rays, and these are my favorite slides because I can turn to the doctor and say, you see, they're all the way down. And this was a great example of just showing how seamlessly they're down. Also, kudos to how far along the intraoral scanners have come, because this entire case was done digitally. So this is we've gotten 100% predictable fit, accurate fit, and verified by X-ray. So we're really starting to see, and even with more stuff like photogrammetry, that stuff you see from PIC or ICAM, we're really getting to a point where we can restore full arches with digital technology without utilizing the analog too much. And right there, you can see that transition between the multi-unit tie base and the multi-unit abutment. And then afterwards, for the final, the patient wanted to make some modifications. So we wanted to head and characterize some of those cervical areas. We wanted to create sort of like a soft transition of pink. So if you look at it, finally, the only trade-off that we really see was the interproximal areas of 9 and 10. And 10 and 11, they had a little bit more of a gingival profile showing. However, in return, we received a restoration that could be easily inserted and taken out, that's easily serviced, that's easily cleansable, and that allowed really for us to restore this patient more long-term, and without any sort of compromise with the screw channel position. So you can see all the way on the right side, the way the screw channels were sealed. And so, yeah, that presented a world of difference for Maria, and she went home a happy camper, and we wish her all the best. But that was one of those examples where we put that 30-degree multi-unit abutment, like I showed you in the slide. We had it on vertical clearance, and then we corrected an additional 25 degrees. For that, the doctor had to utilize the desk angulated screwdriver, which is actually universal in a sense that any angulated implant you restore with desk can be restored with that one driver. You don't need different drivers. It doesn't matter if it's a Nobel, Straumann, and so on and so forth. If it's an angled case, it can be restored with one driver. So it's very easy for a doctor to just go in and use one driver, regardless of the size of the type of the implant. And to finish up, not all medical authorities require proof of fit. Canada Health and FDA does, and in obtaining their certification, DES proved that they produce components that systematically fit the original systems. So a lot of complaints come up with, if you use third parties, they're really good as an OEM. What are my warranties? What are my guarantees? If I'm going to switch over all my production, what are my how is that going to make me feel better? What is there for me? So the manufacturing is top notch. It's fun fact that actually they actually produces a lot of parts for other OEMs because it's the same machinery, the same validation protocols that are used, and they're 510 FDA cleared. Here at the bottom, you see it says Evo H20. It is a great company that us and other labs have worked with, and they allow for really streamlined sort of like FDA compliance for your laboratory. That they utilize a digital platform where you can track all your maintenance, your burrs, any issues with the equipment, serial numbers, anything that requires compliance, and they organize that in a really nice package, and they work with you to kind of get you on board to be FDA certified for certain product lines. So I highly recommend if you looking for someone that can guide you along that path, they're the ones to do it. And here abutment connection is geometry and precision. Abutment connection is geometry and precision machining. So the machining, like I mentioned, are those that a lot of other OEMs use as well. Most connection methods are free from patents, so they get produced freely. And all the components. This is why we work with them. When we work with them, we want to make sure everything's validated, because I can't get 10 tight bases that are good and then the 11th one that kind of like crooked or the hex is off or something like that. So I need that. If I'm going to produce en masse, I need that consistency. That's the word I was looking for. So yes, all the tolerances and dimensions, everything's verified. So each component is inspected visually under the microscope, and their CNC machines are continually monitor production outcome and give automatic warnings if they produce out of spec. So, and we've seen that. We have yet to see any of the componentry come in damaged or without a sandblast coating or with a hexes off. We've seen that from other manufacturers who we will not name, of them trying to do similar things, but there's really not consistency there, which is why we like to stick with this. And the best thing is they actually warranty the implant. So what does that mean? It's the new extended desk warranty is if for whatever reason the implant fails with desk restorative on top, they will, if the original implant manufacturer does not replace the implant, does not warranty the implant, desk will warranty that implant. So really, when you approach your dentist and you say, I really want to use these components, you have a lot of arguments on your side, and you have a lot of assurances to know that long-term, all your bases are covered and using high-quality components. And this is what allowed us to still work together and succeed as a milling center here in New York. So that's it. I want to thank you for joining me today. And Fran, I guess we can take some questions if there's any.
Yeah, so first I want to go over our poll questions and what the results were. So for the first one, are you using desk components for your all-on-X cases? We have 38% of our attendees that are, and 63% are not.
Okay. That's interesting. So that's good. There's still room for growth, and I strongly encourage you to try them. They can all be ordered from Zahn, and if you can order some of their components and utilize a couple of those anterior cases for Angulated screw channel, I think you'll find it very, very good.
And the next one is, are you using angulated screw channels? 60% are.
Okay.
And 2% are not.
Okay. That's
so
good.
Also a good number.
I mean, that makes me optimistic about the future of dentistry. But that is good. Yes. I'm glad that we're all moving in that direction. Are there any questions from the crowd?
Yeah, so I have one question, and it is, if I'm interested in getting started with desks, what is the easiest way to do so?
So the easiest today, and Frank, correct me if I'm wrong, is that they reach out to their Henry Schein rep, Zahn Dental rep, and they will give you a full catalog of what's offered. Zahn will provide you with the library files along with all the components that are currently available. And then once you sign up and start ordering them, then it's just a matter of just filling out that requisition form and getting your parts in. It's the installation process for the library files is seamless. It's less than 10 minutes, and you're good to go. They can also provide you with scan bodies, which probably if you're trying to get a new dentist to jump on the bandwagon, you might have to purchase it for them. Or if you have a nice dentist, just tell them that they can order it from Zahn as well. And Fran, correct me if I'm wrong, they can order them from Henry Schein as well. A clinician can order them from Henry Schein desk scan bodies.
Yes.
Yes. Yeah.
Yeah. Henry Schein Dental for the clinician and Zahn Dental for the laboratory.
Mm-hmm.
Absolutely. And, you know, they're always updating their catalog desk. So there's also an online catalog that your Zahn representative can, you know, assist you in getting a hold of. And basically, like I said, they're always updating. So that's good as well.
Mm-hmm.
And they know how to convert certain things. So that's another, you know, always get in touch with your rep and they'll be able to help you with that.
Yeah.
Also, Evo 820, you mentioned that your Zahn representative can also get you in touch with Evo 820 if you're interested in learning more about their services. So that's, you know, another thing to do. Of course, you highly recommend it, right, Milos?
Yes, yes. It was so easy to use. We have it all on our tablets, and you can have it on a tablet, on a phone, on a computer, whatever. You assign the username, you know your responsibilities, there's schedules that are set for you, profiles, and they work with you really closely to kind of like set you up so that you're all that paper stuff that was done into traditional paperwork before, it's all done now digitally. So it's really useful. We like it.
Definitely gonna keep this open for questions for sure. I'm just gonna go over what's next on Zahn Academy. So next week, August 9th, we have had to choose the right Roland DGA mill with Ian O'Neill. And on August 16th, how to enhance your profitability with desk implant components. And that's with Daniel Alter. So we'll be doing a little bit more with desk, which is really cool. Zahn Dental is coming to a city near you with our in-person events. We have our first hands-on 3-shape design course at our technology center in Wakefield, Massachusetts, which is really right out of Boston. And that's happening this Friday, and we're so excited, and we have a full house, so that's great. We will be having another course, and that's going to be on October 6th. So stay tuned for that. Check Zahn Dental, and that'll take you to our event page if you're interested in joining us in Wakefield on October 6th. 3D printing roadshows, they're also coming to a city near you. That's a 6-credit day course, and we're headed to Mesa, Arizona this month, and that's August 18th. Kansas City, Missouri in September. Orlando, Florida in October. Also in October, we'll be at Long Island, New York. November, Atlanta, Georgia. Also in November, Tacoma, Washington. And back to Fort Lauderdale, Florida, December 1st. So take a look, go to zahndental.com if we're coming to your city, if you'd like to take advantage and join us for a day of great learning and a lot of fun. Milos, I want to thank you so much for joining us here on Zahn Academy. We appreciate you and all your hard work and all the information that you give to our attendees over and over again. Thank you so much, and we wish all of you a wonderful rest of the day.
Thank you, everyone. I'll see you soon. Bye-bye.